Afternoon, everyone. A warm welcome to all of you both here in Brussels at the Renaissance Hotel and also online. We are very excited to be here with you in person after a long time, and I would like to also welcome the online participants. According to my information, we have almost 40 people who are following our event today online. And today we are talking about a very timely topic, namely the European Chips Act. And first I would like to introduce myself. I'm Edina Tóth, MEP from Hungary, member in EIF, and in the Parliament I'm full member in the ENVI committee and substitute member in the IMCO committee. And today I will be your host at this very interesting and important event. And let's now give a warm welcome to our speakers. I would like to start with Pierre Arnold, Member of Cabinet of European Commission Executive Vice President Margaret Vestager. Welcome. Audrey ferrazzini, Senior Director in Government Affairs, Emec, Calcom, EIF Board Member. Welcome to you as well. Bruno de Val, Head ASIC at Network Infrastructure Group of Nokia. Thank you for joining us. And finally, Joe de Bock, who is connected online, Executive Vice President and Chief Strategy Officer at Emec. Welcome, Joe. I hope you can hear and see us. And thank you all for joining us. And now I would like to deliver very shortly my opening remarks. It is widely known that the semiconductor industry is global in scope, and with nearly 2/3 of chips manufactured in Asia, particularly South Korea, Taiwan, Japan, and China. And unfortunately, this dominance has come at the expense of European producers. And we all see that chip production has been high on the EU's agenda, as many technology companies have been struggling to source chip because the COVID-19 pandemic has disrupted worldwide supplies. And as a result, Europe's main industries such as transport, automotive, or defense have been particularly hindered. And for these reasons, on the 8th of February, the European Commission presented a proposal on a comprehensive set of measures to ensure the EU security of supply resilience and technological leadership in semiconductor technologies and applications. And the European Chips Act will certainly bolster Europe's competitiveness, resilience, and help achieve both the digital and the green transition. And as the Commission announced, the aim of the European Chips Act is to ensure that the EU has the necessary tools, skills, and technological capabilities to become a leader in this field, to secure its supply of semiconductors and to reduce its dependencies. And of course, we have to do this all together, because if we fail to find a common approach for the European chip supply, the consequences will be paramount. I think we all agree with this. And it is needless to say that investment is a key to build a well-functioning chip ecosystem. I believe without proper funding, we cannot achieve our objectives. It indeed has a positive message that the proposed CHIPS Fund would facilitate access to finance for startups to help them mature their innovations and attract investors. And we need to support scale-ups and SMEs to ease their market expansion. When it comes to the proposal, I personally have, for the time being, two remarks. First, the objectives of the Commission are high. It proposes doubling our global market share by 2030 to 20% and producing the most sophisticated and energy-efficient semiconductors in Europe. Of course, we all have a kind of big dream of technological autonomy. However, I believe that even if Europe managed to meet the 20% target by 2030, the dependence on Asia should not be lessened, as global value chains are too intertwined and too reliant on producers, especially in East Asia. The second remark touches upon policy making, which does not properly involve market players. I strongly believe that the expansion of production capacity should be mainly driven by market demand. And to conclude, the European Chips Act will certainly be a game changer for the global competitiveness of Europe's single market. And consequently, the lawmakers should listen to industry to see what the needs are. And with these words, I would like to give the floor to our distinguished speakers to learn more about the Europe semiconductor market and the policy solutions. And after the 4 presentations, there will be a Q&A session. First, I would like to give the floor to Priya Arnold from the European Commission, please.
Thank you, Member of Parliament. Good afternoon, everybody. I'm really happy to be here today to explain a bit what the Commission's proposal is. But before that, I think what is maybe as important as the proposal is the context in which it has been made. And you already started raising this point, but I think it needs to be really clear. So the COVID-19 crisis and the ongoing shortage of chips, they reminded us of 2 very important lessons. So things we should have known or we already knew, but we could experience it. So first, that semiconductors are essential for the entire economy, and it will be more and more the case. So it's not only high-tech companies that rely on chips, but it's more and more all kinds of companies. And the automotive sector was a very good example during the crisis. And it is necessary to have chips to secure the twin transition. And in particular, of course, the digital one, but it may also help for the green transition. The second lesson that we learned is that we are in a sector which is in an exceptional situation because we depend on a very limited number of factors and a very limited number of countries which can produce chips. And it's more and more concentrated, in fact, this production, because it's extremely capital intensive. And of course, we have a very complicated geopolitical context to take into account. So these 2 elements, exceptional sector for the economy and exceptional situation, justified the need for an action by the Commission, which was mentioned, announced by the President last year in the State of the Union, and we were happy to be able to deliver a proposal quite quickly. Of course, with the war in Ukraine, we have a second reminder, and the member states also called the Commission for action. So that's the context, which is very important. As to the proposal of the Commission, 3 pillars. So one is the Chips for Europe program. The second one is security of supply. And the last one is about monitoring and crisis response. So the first Chips for Europe program is extremely important because it's about creating technological capacities in Europe. And that if we manage to do that, that we can be successful on the long term. And here we expect contribution from all stakeholders in the value chain. The main elements will be the pilot lines to bridge the gap between research and production, but you will also have virtual design platform and network for competence center. The second pillar, security of supply, quite telling by the name. So we want to accelerate production, the implementation of production facilities in Europe. And in parallel of the regulation, we also explain better how we would apply the stated rules and stated enforcement to these new chips production facilities. And here, what is very important in 2 words is that we are not creating new rules, but we take into account the exceptional sector and the exceptional circumstances, and we apply them to our rules together with strict requirements to ensure that the balance is met. The last pillar about crisis monitoring and response is about anticipating future crises by getting the necessary information, and in case we have a crisis in the semiconductor value chain, to be able to act as some of our partners can, but we could not, as we have seen in the current crisis. So that's what I wanted to present to you, then maybe a few remarks to conclude. So one, I think I repeated enough that it's an exceptional circumstance of an exceptional sector, but the idea is that the CHIPS Act is not a blueprint for the entire economy. And by the way, there is also a consultation ongoing on the Single Market Emergency Instrument, asking all stakeholders what tools could be used to anticipate and address future crises. So you're welcome to participate to that. You still have a few weeks. It started last week. The second remark is that it's an opportunity not only for the semiconductor value chain, but for the entire economy. And the objective is also that we facilitate adoption of new technologies by different sectors, not only that we produce. And the last remark, which echo what your conclusion as well, is that we are not doing that alone. We know that Europe will remain dependent for some parts of the value chain. So what we are trying to do is to move from an extreme dependency towards certain companies and certain countries or geographies to a more interlinked world of dependencies with also our partners. And we are working together with also our partners too. We want to make us also more attractive for them. Thanks a lot.
Thank you very much for this very important speaking notes, because I think it's very important that we well understand the Commission's proposal. And now I would like to give the floor to our next speaker, Audrey Ferrazzini from Qualcomm, also EIF board member. Please.
Thank you, Edina. So you can hear me well, right?
Yes.
Okay. So I would like to start by an anecdote, because not everybody, I would assume, in the room knows what are exactly chips. And when I joined Qualcomm 10 years ago, my struggle was to explain to my family and friends what were chips. And when you don't see something, it's difficult to capture what it is. So I was saying, you know, it's kind of magical, it's like air, it's everywhere, but you don't see it. My family didn't buy it. They were very, very nervous about me joining a US company. But still, I think this kind of analogy with air is very important, because, you know, when it's present, you don't need to notice it. When it's absent, you really get that you really need it. And that's a little bit the superpower, I would say, of chipset. Now we know that they are very strategic, you know, they are fundamental for the twin transition, as mentioned Pierre Arnold, and they are as well essential for a number of goods that we cannot live without. So just mentioning smartphone, cars, laptops, consumer goods, like all of them, you know, we noticed that, but as well energy grid. So they are a component of this kind of twin transition. I would like to give some numbers to start with, and it won't be that long, okay? But numbers are very good as well. So in 2021, despite the crisis, more semiconductors were sold than any previous year in the world. So it's kind of an history in this industry. In terms of market now, it represents roughly $550 billion right now, and it's expected to grow to $1 trillion by 2030. So it's a very important market. I will make some very, I would say, short point on partnership, on the CHIPS Act, on Qualcomm vision, on being a fabless company. You might not know what it is, but I'm going to tell you what it is, and the importance of international cooperation. About partnership first. So Qualcomm is the US world-leading fabless company by revenue, and we're supplying semiconductors to customers from automotive, Internet of Things, robotics, Industry 4.0. And we really want to be a partner to Europe as it builds its chips capabilities. I said that we are a fabless company, and this is how we're known, but in fact, we have a secret. We have a fab in Munich. It's a small fab, but very important because we develop manufacturing and design, R&D, innovation, and first industrial deployment activities for fast-growing segment, especially for our European customers in industry. So what do? We develop filters for 5G and 6G for vertical sectors. We're part of a German IPSI project, so it's a project of European interest. We just sent our application, it was accepted, and we have applied to the European Alliance launched by Commissioner Breton a few months ago. About the CHIPS Act, we really support the European CHIPS Act and its ambition to boost production by 20% by 2030. And we are as well in favor of a European-US objective of reaching 50%, which is extremely ambitious, of global production. And our vision is very simple. We need a little bit of everything. Because there is a growing demand. It's true, it's exceptional, but at the same time, we are in the middle of digital transition. So, quick course about the nodes. You probably heard about nodes and disputes about different sectors talking about what we need. So you have the leading nodes, you have the advanced nodes, and you have the mature nodes. We need everything, not just Qualcomm, but the industry needs everything because we can adapt. So very quickly, I would say about the size, the legacy mature node are plus 40 nanometers, the advanced 1028, and I would say the leading edge, which is as well one of the heart of the CHIPS Act, but everything is part of it, this is 10, sub 10, and below 10. And this, you will have a quiz after just to make sure that you got the different size. But just to give you some example, our Snapdragon 8 Gen 1, so it's very for geek people, but the processor, it's a 4 nanometer, so very, very in the leading edge category, and it has 10 billion transistors. I will stop with the number with the last one, just for you to know. In a smartphone, you have 169 semiconductors for every smartphone. And in fact, until now, you have roughly 70% that belong to the legacy node. So not everything needs to be leading edge. I still have 2 minutes, I guess, if I'm... Being a fabless, so we are the first semiconductor company to adopt a fabless business model. It means that we invent, we design semiconductor, and we are working with partners for the production. This is explained as well in the EU CHIPS Act. It's a model that has been adopted by several players after. What it allows, because it's a very condensed market, it allows manufacturers to ramp up quickly and produce very high volume, because you need the fab to produce, I would say 20 all the time. And thanks to this model, in fact, they are able to compete, innovate, and grow. Qualcomm has been working with any new foundry that has been successful over the past 10 years. Last point about international cooperation. The way that we are seeing it, and this is our vision, we need to think collaboratively to build a geo-diverse supply chain. Why? It's kind of obvious, but it's important to repeat it. One company or one region will not be able to fulfill I would say, the need and the growing demand that we are seeing in the market. The other point, which is as well very important, it's not just about production, it's design. It needs a really holistic way to think strategically about this sector, which is very foundational, for other sectors. So we need to think about production capacity, we need to think about talent, we need to think about R&D, and as well we need to think on how government can share information about demand. And my last point, and then after I stop, I wanted to mention a few words about the TTC, the Trade and Technology Council, because we believe as Qualcomm that it can address some common matters that we are discussing, both on the US side and on the European side. It can help foster dialogue and mutual understanding as well, create synergies, and what is extremely important as well, because it's scarce resources, we need to avoid any subsidy race. This will, according to us, will foster a constant cycle of innovation, which we desperately need, and foster technology leadership on both sides of the ocean. Thank you.
Thank you very much for your presentation and also giving us concrete examples, because these all help to better understand the topic. And now I would like to give the floor to Bruno de Val from Nokia, please.
Okay, good. You can all hear me? Okay, good afternoon. So what do we do at Nokia? We create the technology that helps the world act together. So let me see whether my control works. Yes, okay. So put it simply, we create the world's networks together with our customers. 6.6 billion subscriptions are supported by mobile networks, and 500 million fixed broadband lines connecting homes and businesses around the world are built or maintained using Nokia technology. So the majority of our business is within the telecoms industry, and chips do play a crucial role in the strategy of each of our business divisions. Fixed networks, IP networks, mobile networks, and optical networks. Each of these divisions is really focused to build technological leadership and to bring next generation superior technologies to the market at an acceptable cost, and with a big focus on energy efficiency. Nokia's Quillion, FP5, ReefShark, and PSZ are the most recent successful proof points of Nokia's investments in building application-specific integrated circuits, or like we call it, ASICs. And that's one type of chips, and I will come back to it a little bit later. So who are the people making these chips? So we have at Nokia around 11 excellent centers for chip development in Europe, working for these 4 divisions: mobile, fixed, IP, and optical networks. And it really means more than 1,000 people, chip development engineers working across 7 countries: Finland, UK, Belgium, France, Germany, Poland, and Italy. So if we talk about the chip industry, it is very important to realize that there are many different types of chips. It is impossible to develop a kind of generic chip that can be used in every market in the industry. So in every market, every product supplier needs to make a choice between making or buying a chip, a choice between building a product with general purpose processors that can be CPUs, like you have in a PC, with application-specific standard products, or with customer-specific standard parts, or maybe with field programmable gate arrays. These are all different types of chips which you can program, or you can make a choice to really make a full custom chip for a specific market and a specific application. That's what we call an ASIC, and at Nokia we have decided to invest where possible in these custom chips, these ASICs, because it's really required in the telecom market. It's required, why? Because we want to be competitive, of course, and that means on all fronts. On feature set, on performance, on quality, on energy efficiency, and product cost. We are in a world where our competitors have also increased their investments in ASIC development significantly over the last years. And also important for the telecom market is that we really have access to these newest state-of-the-art silicon technology nodes. And you got the explanation of all the different nodes. So we are really using 7 nanometer, 5 nanometer technologies for our current programs. And we expect for the coming years that we'll keep on using these advanced technology nodes. So why do we need these advanced technology nodes? That is really, the smaller the nodes are, the more functionality you can integrate into one chip, the higher the performance will be. And last but not least, power can be reduced from one product generation to another one with that, on average, let's say 50%, which is very important also for the green agenda. So if we look, and this is my last slide, if we look at the development cycle from really an idea to an integrated product, a chip development team really goes through different phases with specific activities in each of these phases. And different industry players span different domains with varying degrees of vertical integration, like we call it. Having production facilities is just one element, right? It's not enough. It's one element out of the many in the value chain, and it is important to have secured access to all steps in this value chain, which doesn't necessarily mean that we need to localize every step in this chain, like also has been mentioned before. It is crucial that all these elements in the chain need to be cost-effective to be able to succeed in the industry, in the market. In the Nokia chip design teams, for the moment, we focus on all front-end design activities, and that means we have dependencies towards specific third parties for what we call IP blocks that we can integrate in our chips. And an IP block can be a generic type of block that can be an embedded processor, a memory element, a serial interface IP, something that is an IP block that can be integrated in what we call these custom ASICs. Another important aspect is what we call the non-recurrent engineering cost, or the NRE, that we need to pay to develop such a custom ASIC for our products. That really has been going up significantly, of course, for each new technology node that is coming on the market. And the amount of different third parties that we work with, for example, for backend design, for foundry, packaging and test, the amount of third parties really has been going down significantly over the last 5 to 10 years. And those third parties have been mostly outside Europe. So we really hope indeed that the EU Chips Act will help us to build an even stronger ecosystem for chip development in Europe, helping us to address the challenges in the market and definitely also the challenges we have in the telecom market, because this is also a crucial market which is providing the network infrastructure that we are all using in our daily life. Thank you.
Thank you very much, Bruno, for sharing with us the views of Nokia. And me being member in the Environment Committee, I was especially pleased how much you stressed the importance of energy efficiency as well. And now I would like to give the floor to our last speaker, Joe de Boac from Emec, who is connected online. Please, the floor is yours.
Thank you so much. Let me just check whether I am clearly audible in the room.
Yes.
Excellent. So thank you and apologies for being the only virtual speaker on the panel here. I'm stepping in for my colleague, Anne van den Bos, who could last minute not join. But it's a pleasure to talk about this very exciting topic in very high turmoil times. My comments will be coming from one of the players in the ecosystem and in general the setting of research and development, which as was mentioned by Mr. Prue, is the first pillar, one of the 3 pillars in the CHIPS Act, looking at supporting the R&D and the development of new innovations in this area. Emec has been one of the front runners over the past 3 decades in developing chip technology. That was so eloquently explained by Bruno de Val just a minute ago, and referred to air by Ms. Ferrazzini earlier on, because indeed it is present everywhere. And what I'd like to emphasize in my short introductory intervention is the fact that it is indeed, there is a strong need for doing this full stack innovation in order to bring success to the ambition, the high ambition, as was mentioned by Ms. Todt in the beginning, the high ambition of the European Chips Act. And one of these elements being the pilot lines, and it's a bit of maybe a strange concept, but if you look at the full stack innovation, it's not too hard to understand that when one wants to innovate in this domain, you need to see all of the trends, and you need to act before the manufacturing is ready to supply the new technology. You need to act in R&D before that time arrives. And that means that you need to have places where you can test, you can explore, you can virtually or in real life prototype some of these technologies. Now, if you look at a pilot line and you consider the full stack, one element, and we shouldn't forget, is one of the strengths of Europe, is the fact that we play a very significant role also in the tools, the equipment, materials for manufacturing. There isn't a single high performance chip worldwide produced without European technology. And we think about lithography, for instance, ASML, but also other tools and tool manufacturers that play a crucial role in this ecosystem. It's a bit overlooked, but it's important for those companies to find pilot lines in Europe that in which they can show off and demonstrate their new technology. But from the tools and the manufacturer equipment, you need, of course, to then go to the production itself. And it's been mentioned as one of the important elements of the CHIPS Act, Pillar 2, to build capacity to further enthuse production in Europe. And therefore, of course, it's needed. A lot of investments are needed, but also skills, so talent, also IP and European tech. And I think that's where organizations like Emec, in conjunction with industry, because that's our role, to innovate with industry, not just for industry. So that conjunction is very important. And there, the IDMs, the companies that still produce and will in future produce in Europe, will need to find a solid base in this collaboration with institutions and leaders like Emec, die Fraunhofer, and many other of those RTOs. Beyond that, and that was again well explained earlier, is the fabless layer. And those are the companies that start to think very early on system level innovation. How will the future car look and what type of integrated circuits need to come in? How do we design these? The same for, of course, the telecom sector. How do we build a 6G infrastructure? And we can go on. And one topic which was not mentioned yet is healthcare. There's a lot of future healthcare that will heavily rely on innovation at system level, building on data, and hence also building on semiconductor technology. So having said that, these fabless companies are very important, and they're also present in these pilot line infrastructure because they are the ones that try to innovate in, as I said early, before the technology is really maturing, try to innovate and see where system innovation comes. And this is what we call the system technology co-development, co-optimization. It's more than just looking, to build an ecosystem. It's actually innovating through the ecosystem. And we shouldn't underestimate the power that Europe has in comparison to, for instance, the United States and other regions in having this fabric in place for doing this cross-stack innovation. Of course, the only way to do this is to virtualize this technology. I mean, some places will have large and very expensive pilot lines because they need clean rooms, they need the investment on the tools, but we need to virtualize these infrastructures across Europe with the design centers. And the virtualization is already ongoing. A lot of chips are being designed through cloud-based infrastructures, software that is running virtually in the cloud. But we need to then proliferate this type of infrastructure throughout Europe and build competences, build skills in every member state, just that, the access to the facilities that are pilot lines is open and ready for innovation for everyone. And of course, at some points in time, and the sooner the better, we can then transfer technology when they've proven their potential, and also opened and created the market, created the demand through this the early access to the technology. We can then transfer the technology to the partners that we already have in this collaboration, the industry that wants to further take it up to production because the volume is being explored. So this could go through existing companies. We strongly embrace non-European leaders coming into Europe, like Qualcomm for one, but of course also Intel, TSMC, and other companies that are keen to invest in Europe and maybe specialize for the technology, because there's no such thing any longer as the transistor, the node. There are specializations needed, and this specialization particularly we can do in this collaboration on the pilot line. So I think I overstated already my welcome here in time, so I'd like to keep it here. So we need to strengthen the European strengths. We need to create a demand through prototyping and invest in technology leadership in semiconductor, because it is transforming all of the critical markets in Europe.